Hello, everyone, and welcome to the Harvest Dental Products in DGShape present TriLor and DGShape. Thank you so much for joining us today. Hopefully, all is well in this new world that we're in, and wishing everybody to be very healthy, successful, and happy. So, thank you again for joining us today. So, for some of you that may not know me, my name is Daniel Olter. I am a professor in New York City College of Technology, as well as a executive editor for Inside Dental Technology. I am also a former laboratory owner in Long Island, so I understand the points of views and the challenges that laboratories face with every day. And that's what makes me excited about this particular product that we'll get into in a second, where it's really versatile and really is a benefit for the laboratory. And we'll share in a little bit what those benefits are. Certainly the quality and the ease of flow and work, but also the profitability for some of these very high profitable type of restorative options, and I'm excited for it. Today, joining us today, and again, my good friend Ian O'Neill. He is the East Coast of Dental Sales representative for Roland DGA. He has 5 years of experience as a CAD/CAM training and installation specialist, as well as 12 years of dental laboratory experience in both traditional and digital restoration process. He's incredibly knowledgeable, and I'm proud and happy to call him a dear friend of mine. So Ian O'Neill, thank you so much for joining us today.
Hi, Daniel. Thank you very much for having us here. Excited to be a part of this.
Fantastic. So why are we here? We're here because we want to know about TriLor, right? So what is TriLor? TriLor is manufactured in Milan, Italy by BioLoren. It is a Harvest Dental product, is an exclusive distributor here in the US. TriLor is a high-performance techno-polymer matrix. I know it's a very big word, but in reality, it's a polymer that has a multi-directional glass fiber reinforcement for strength, right? So it's 75% glass fiber reinforcement embedded in a matrix, a resin matrix, a composite matrix. So, which makes it a perfect type of material of choice for implant-supported restorations, whether it be bars or whether it be thimble type of restorations, which are Toronto bars, which are again a bar, but now they have preparations, which we'll show you in a second, that will subsequently take individual crowns for, that have so many great benefits that in and of itself. But what makes TriLor unique, it's different than the predecessors that we've had, which are the titanium or the zirconia, right? Titanium and zirconia have been used for a very, very long time and have attained some great success. However, those materials are very, very rigid, and they are not forgiving. They have no give at all. This is where these type of materials come in, and specifically the TriLor, because it is so incredibly strong, but yet is very forgiving. So what does that mean? What does that mean for implants and for restorative implant situations? If the materials such as titanium and such as zirconia is utilized, and the biomechanics are not taken into consideration, what ends up happening is it transfers down into the weakest area, shall we say, which ends up being the bone with the implant. So what we're seeing is over the years is that some of these restorations are coming back with failed implants, and it's not because the implants, it's just the way they were designed, and certainly it wasn't accommodated for any flexural because it's so rigid with the material. And this is why I'm so excited about TriLor in particular, because it affords the flexibility, it affords the force absorption, and quite frankly, it protects the implants from failing. So if you're having an all-on X, whether it's 4, 5, 6 implants, whatever have you, you want to respect the biomechanics in order for it to make sure that it functions and it's properly well. Not to mention that also the mandible oftentimes has a natural flex to it, right? From the condyles into the middle, there's a little bit of a flex, which the TriLor material really absorbs that flex and flexes along with it. So it's a tremendous benefit, and there's other benefits that we'll get into as well as repairability, lightweight, which is about 1/5 of the weight of its counterpart in zirconia, as well as keeping everything quality controlled in your laboratory, making sure that you're designing and then being able to output it. So I'm excited about this material because it really has a tremendous amount of benefits for the laboratory, benefits for the clinician, and certainly benefits for the patient, which is first and foremost our patients. but it makes it unique, and it also affords for these type of parameters. It is, I have to say, it is also owns a European SCE, as well as it is FDA USA, as well as the Brazilian certificate for permanent prosthetic material. So that's big. It's not like a typical polymer that you may think of. It's directed, or it's indications for a permanent prosthetic material. So it has a tremendous amount of versatility. You're able to create some really significant and wonderful looking restorations while resting assured that it is strong enough, as you see here with tensile strength and flexural strength and so on. But it's strong enough to maintain in the oral environment due to those forces and not fail. And most importantly, as I said, it doesn't allow the failure to occur at the implant site, which is the most important thing. So you want to make sure that anything that you put in those implants, whether it's All-on-X and whatever have you, is protecting the biological of where the implants are facing. So as far as comparisons, TriLor, this is the comparisons of what can be, and just notice the tensile strength, where it's incredibly strong with 380 megapascal as compared to some of its Trinia as well as Pecton, which is 115. The Peak is 100 megapascal, and Zirconia is certainly it's as hard, but not close. It's even TriLor is even harder in tensile strength than what Zirconia is, and obviously chrome cobalt. As far as flexural strength, you can see that it's also significantly higher than any of the others or any of its comparisons, other than Zirconia, which is at 1200 megapascals, which makes it very, very, very strong, obviously. But all we need is really the strength of, the TriLor to really accommodate, and it's shown that it's really has weathered well, and in fact benefited the implant restorative space and solutions in the process. So that brings us to why focus on this? And certainly materials, there's an abundant full of materials that we can utilize with not only TriLor, but titanium and zirconia as well. But as far as TriLor is concerned, there's a tremendous amount of interest in this market. And so I quickly looked at what the implant market is currently right now. It is one of the fastest growing market that is existing in the dental space. Other than digital dentures, this is the second largest, or it may very well be the first largest, because there's different variables that allow for this type of market to really grow and expand. So for one, there's a higher percentage of GP placing implants than ever before. Specifically now with the pandemic, GPs are looking to produce more revenue for their businesses than they've ever done before. They're more eager to restore, and significantly similar to the laboratory space, implants tend to provide a significant amount of profitability for clinical as well as for laboratory. Furthermore, it also with digital, now it's become more predictable surgical and restorative results. Now the laboratory can engage from the get-go, in creating or virtually placing implants for that clinician, right? And then subsequently with approval, being able to go ahead and create a surgical guide. So that's a tremendous amount of, for most of the laboratories are utilizing, or rather serving, GPs, right? So imagine having a resource of your clientele and being able to offer them a value add where perhaps they're doing implants or they're not doing implants, but you're able to holding their hand while they're doing implants with the success, right? But what occurs with that kind of scenario is not only are you, involved from the get-go to make sure that the restorative protocol is proper, but you're planning it through, you're virtually placing the implants, you're creating a surgical guide for that GP or that surgeon, whatever have you, and you're there through the process. But in reality, you own that case at that point because the success is already predetermined from the very beginning. So you're able to be there with that GP, place those implants. Obviously, the GP places that implant with the surgical guides, but then you're able to, whether you're doing an immediate conversion or whether you're doing it in the laboratory, a bar, or an overdenture, the ability of tapping into this resource is tremendous. And there is a a significant profitability that you can benefit from as a laboratory as well. So look at this. If you're not in the implant market, or if you're very little bit in the implant market, or if you're scratching your head and saying, how do I get more into the implant market? They're all right there. Your general practitioner, dentists are all eager to learn and understand and realize more of the revenues, and this is the ability to do so. Now, with that said, that's where the TriLor comes in really well, because it is forgiving, as I said. It does have flexural, but it is also biocompatible. It is metal free, and it's incredibly lightweight. So it provides the patient with the feel of though they've had their teeth, and it doesn't feel foreign. It doesn't feel anything different, and it flexes, as I said, similar to what the mandible does. So enhanced precision and fit, certainly, but tapping into this market is where you really want to tap into. But who are these patients, and what are they, the metal-free implant solutions? I mean, whether it's your uncle, your brother, which it could be your grandfather, your mother, your father, any kind of, all these patients are somebody's mother and father, somebody's aunt and uncle. By having a material similar to this, not only are we enhancing their health, that they can properly gain the nutrition that they need, but there's a overall quality of life that is enhanced with this. And certainly with a metal-free implant solution, it provides them, it gives them a way out of their denture that feels very foreign. They want to feel like they're chewing with their own teeth, which with implant, and specifically with a metal-free implant solution like TriLor, it provides that sensation of it's their own teeth, because it's so incredibly lightweight. It is about a fifth of the weight of its counterpart in zirconia. So imagine an arch in zirconia or an arch in TriLor. And I have to say, with the thimble and the Toronto bridge, what it means is that it's a really innovative type of bridge, whereby it creates we're able to digitally design and create a bar with individual preps that then subsequently we're going to place crowns, individual crowns on, similar to Emax, lithium disilicate, or even zirconia, whatever have you. Now, and then build the gingival part with composite. Some do with acrylic. I prefer with composite, because it does give it a better look, an aesthetic look, and you can characterize it really nicely. But it offers such great benefits for somebody's grandfather, somebody's aunt, somebody's mother, and somebody's brother, because what it does is, as I said, it's lightweight, it's metal free, but if there's ever an issue anywhere, the laboratory already has, let's just say, number 8 distal chipped off, and now the patient's calling the dentist. If it was in zirconia, we would have to start from square one, right? We would have to begin again, because if anything breaks off, or even if it's overlaid or the actual core zirconia, you can't necessarily repair it very easily. With this, it could all be repaired, and it doesn't even have to go back to the dental laboratory, because if number 8 has chipped off, now it's very easy. Dr. Jones calls your laboratory and says, patient so-and-so, their number 8 chipped off. You can very easily say, okay, no problem, doc. We have the STL file from that crown. Have the patient come this afternoon. We'll have that crown ready. Mrs. Jones shows up at the dentist, and then the dentist just removes number 8, and they have a brand new, same restoration as they had before, with very little effort. It's less of an intrusion or disruptive for the dentist, because now they don't need to remove the prosthetic, send it back to the laboratory for that repair, wait 2 weeks, have the patient wear an intermediate in the meantime, and then have them reappointed at this 2 weeks later, once the laboratory finishes processing theirs. Now the workflow is significantly easier. All they do is they remove that crown, which is very easy to remove off of the TriLor, and then subsequently place a new crown in, and off the patient goes. Even if for some reason the tissue resorbed or the gum resorbed, this material, being that it's 25% composite, can be repaired intraorally. So with direct composite, the dentists themselves can add to any deficiencies. This all makes the workflow better for the laboratory, the clinician, and the patient, because of the time savings involved. It is metal free, it is biocompatible, as I said. They don't feel like it's a very heavy weighted object. They don't, it's funny, oftentimes when patients see like a metallic bar or metallic anything, their first thing that they think about is the James Bond movie, the Jaws. you know, and it's one of the things that I actually tell my dentist not to use the mirror anytime that they do anything with metal, because patients quite honestly freak out when they see metal, and especially like a bar or any kind of metallic in their mouth. So this is a solution that can really provide an ease for the clinician as well as the patient, obviously. And there's so many benefits to the laboratory. So just again, it's truly to replace unforgiving metal zirconia. That's where the benefits really are. As I said, with biomechanics, any type of strength, anything that is incredibly strong or incredibly hard, if it's not forgiving, at some point, and this is with biomechanics anywhere, it's going to trickle down to wherever the weakest point is. And unfortunately, in a scenario as an implant supported prosthetic, the weakest link when it comes to zirconia or it comes to titanium, metal framework, even chrome cobalt, is unfortunately the implant, or rather the bone around the implant, which is going to suffer the constant hammering of the mastication forces. So it will eventually fail, and that becomes a catastrophic event where now you have to think of how do you repair or how do you save this implant, or does the dentist have to remove it and then place another one? It sets off a whole series of consequences or unintended consequences that become a trouble or challenging spot. So utilizing a material like TriLor forgives or provides a way for the material to absorb those forces in the process. So that's what I'm, very excited about. It is also a metal-free, biocompatible solution. As I said, it's incredibly affordable. What you can get from a puck, you can easily get about 4 arches per puck, and it's affordable because it also provides you a quality control in the laboratory, and now you know what your outlay is, different than perhaps zirconia, which would take up the majority of the puck, as well as there's so many other labor-intensive parts to it. But with its titanium counterpart, which most laboratories outsource to get it, it becomes costly, and you're sharing the profitability with an outsourced center. This allows you to bring it in-house. This allows you to control the quality, see exactly what it is that you're doing, and overall, it also allows you to control your costs in it as well. Similar to the cost with time saving, outsourcing titanium bars takes time. It is what it is. You send it out, it takes a day or two. If you scan it and send it, then perhaps it comes in that day. However long it takes for that outsource center to produce it and then ship it back to you, typically within a day or two. You're looking at, close to a week in time just being able to accommodate that. Whereas opposed to that, if you do it in lab or in-house, you can design it perhaps, and let's call it, an experienced technician can design something like this in about half an hour to 45 minutes. You can mill it, which would take about let's just say a little under 2 hours, and Ian can speak to that when he gets to it. But in reality, you can have a finished prosthetic, done in a fraction of the time that you would need to do it, sending it out to an outsourced center. So not only is it better as far as profitability, but it's also better for the workflow, and you can dictate your time, your quality, and your costs with this material, which brings it all in-house. It is high strength and lightweight, so it is strong. So we've even beta tested it for. I've had some friends beta test it, and they've tried destroying this material, literally. Things that perhaps a patient, certainly I hope a patient never undergoes with any of these implant restorations. What some of my friends have done, and I am happy to report it steadfastly through these type of experiments. It's very, very hard. It's very, very difficult to break. And in fact, none of them were able to successfully break it. That's how hard it is. But it's incredibly lightweight. It's remarkable when you hold it in your hand how heavy zirconia is as compared to this material. And to think that it's as strong and as forgiving, or even more forgiving in the mouth, is just remarkable. Something I'm particularly excited about for the overdenture for the bar cases is the aesthetics also, and with pink coming. So we've made a request to Italy to produce pink TriLor, which I think is a real game changer, because when you're doing, you know, a bar, for argument's sake, a regular bar, and you're doing a wraparound denture over it, there's always the worry, whether it's in titanium or in any of the other materials that are bone in color, how to mask it, right? And will it compromise my thickness of the denture? And what does that mean for the denture? And how do I go about doing that? So a lot of folks, and you know, what they've done is, whether titanium or the bone color, the peak or whatever have you, is that they had to use composite opaque in order to hide that or mask that, and then use, you know, compromise some of the thickness perhaps on either the denture or the bar, in order to not have something very protrusive in the mouth. Now with the pink, there's that worry is gone, because the pink and pink obviously blend well into each other, and even if the bar is very close to the acrylic, you know, it won't be decipherable, and in fact it's going to actually be stronger, because it's a more of an aesthetic type of restoration. So then how do you go ahead and do you fabricate TriLor? Now there's several ways of fabricating TriLor. Certainly there's the bar, so I use mainly DGShape. So there's the designer bar, you can, and there's multiple ways of kind of attacking it, and I've seen others there. In 2020 now, there's in DGShape, there is a workflow for this type of thimble bar, but before that, and there are libraries that are available, and in fact the TriLor library is being introduced October 1, where you have different preparations into it. So you can design a bar with attachments, similar to what you do with titanium and so on. You can design using anatomical cutback. You can also design, and you can also wax up an understructure and copy mill. So there's different ways of creating that. And the full, complete TriLor solution, as I shared with you, is going to come out on October 1 with the real launch, where it's going to have a thimble library. So you're going to be selecting in your order form, or you a bar with, actually, rather before a bar, you would be selecting, you know, regular teeth, and then connecting it, and you're going to select the library that are thimbles or the preparations. And that's really nice, because you have a millimeter of reduction, you have a millimeter of a clean margin that you can utilize to then go ahead and subsequently, you know, design your crowns to go over it. So it's a versatile, and do look out for it. But you can either do a regular bar for a wraparound, you can do a bar with attachments, or you can do this cutback Toronto that I'll show you in a second, that you then subsequently put individual crowns. And that's really a huge benefit for the dentist as well, because they can, as I said, repair things, make changes. If they want to try in the bar or the Toronto bar or the thimble bar prior to the crowns, they can. And with composite, you can very easily do that. So some bar designs and some things to think about, similar to here. This is where you can actually, if you use the option of the attachments, then you can place attachments. This is not one of my favorites, but it does work. So whether an attachment or whether a locator or whatever have you, you can do with preparations similar to this, and you end up getting a bar with a wraparound. You could also utilize TriLor, and I've seen Deutsch Laboratory do with the telescopic copings, which really come out really nicely and well. So these are the thimble bars that I was talking about, and each individual one is a preparation of sort. This is versions before, and they've gotten significantly better, but you can see where we adequately blanch the tissue while looking at the preparations to make sure that everything is proper and correct, and then we can design our restoration thereafter. So imagine being able to, now with a bridge like this, not only are you utilizing the aesthetics of perhaps you know, lithium disilicates or other type of restorations, perhaps even layered restorations, feldspathic restorations, whatever have you, but you're in full control of your restoration. You're in full control of being able to design something like this, being able to then go ahead and subsequently make individual crowns. You can mill them, you can whatever have you, compress them, and then you layer a composite over the gingival aspect of it. The results are truly amazing, and I'll be able to show you that towards the end of this presentation some of the results that Jay Black shared with us, which really were phenomenal. But it's truly a versatile material that is, as I said, is bio compatible, lightweight, metal free. But most importantly, what I'm excited about is having the control in the laboratory, having the control within you. Your dentists have come to expect the aesthetics and the results from your laboratory. The moment you outsource out either part, either titanium or the zirconia, or even the zirconia with some of its limitations, you want to maintain that control, not only for the quality, but also, as I said, for the time and for the profitability. Now you have the ability to do so with a material that is better for the patient as far as the, the flexibility and the absorption of the material. So it's exciting. I encourage every one of you to try this material, and certainly have a conversation with your dentist to see what the benefits are. And you'll see once you explain the benefits to your client dentist, their options and their eyes are going to light up, because it makes sense. It's something that is easier and more forgiving to the patient, something that is easier and more forgiving to the clinician to use as well, and the benefits that I shared about for the laboratory. So with that said, I'm gonna release my screen and have Ian share his screen, because we want to go into what the benefits are and how to utilize significantly the with the amazing Roland mill.
All right. Daniel, can you see my screen at this point?
I can see your screen, yes.
All right, beautiful. All right, Daniel, thank you very much again. My name is Ian O'Neill. I'm the Eastern U.S. sales rep with Roland DGShape, and I'm very appreciative to have the opportunity to be here to work with Harvest on the TriLor product. I've had an opportunity to actually work with this product hands-on and produce it inside of the Roland DGShape mills, and that's what I'm here to talk about today. Roland and DGShape provide the most popular dental milling solution here in the US today. And with so many units out there in the market and a great material like TriLor available, we wanted to give you the steps so you feel comfortable and you feel as though you can be successful. So let's dig into this a little bit here. So today our current offering from DGShape is our dry mill options are the 52D and the 52 DCI. So there's probably a lot of you watching this who probably even have these mills. They are 5-axis dry mills. They can produce types of restorations ranging from zirconia crowns and bridges, full arch restorations, wax for casting, PMMA, snap-on smiles, as well as some other unique materials like a TriLor or other materials that are out and available right now. So one of the unique things about these two mills and these milling systems is if you have yourself a 52D mill and you increase your production, you grow your business, which is really the ultimate goal, and then you add a DCI for overnight production capabilities for things like bars out of TriLor, zirconia arches, maybe removable products, removable restorative solutions. We have a clamping device system which is interchangeable between the two mills. So the Mailbox Software, which is the CAM software most popular with these machines, would calculate those files, and both of these machines would accept the adapters. This streamlines your workflow, reduces fracturing of zirconia puck edges, and overall makes you just more productive, more organized. So some of the other highlights of this mill, I've already mentioned that it is a 5-axis mill. It is a ball screw drive system. Some of you may be familiar with some of our older models. The one I'm talking about specifically, the DWX50, extremely popular. Really where we made our mark in the business was a wire drive system. So with the newer mills, we moved away from that type of technology, moving to the ball screw drive, which is more accurate. It's able to move those axes more slowly, overall giving you a better result on your restorations. So that 5th axis is very important for jobs milled out of something like a TriLor material, because maybe it's a full arch with gingiva and prep or a bar substructure. We need that 5th axis to be able to reach those undercut areas and make sure everything is milled out in perfect detail, just like you designed it in your CAD software. So 5th axis is very important for jobs like this, We do have the intelligent tool control technology. This is newer when the 52 series came out, with the capability of running your machine overnight, a variety of milling materials or tools that can be called on for specific jobs. We knew that it was important to be able to give customers the option of running a job overnight and not having to worry about a tool. So when a tool reaches its maximum hours of use, the machine, once it places it back and goes to a next procedure, the next time it needs that same size tool, it's going to know, as long as you have it registered, to pick up the sister tool and continue that job. So that's really important in machines like the DCI, where you have overnight capability. You're not going to have a third shift on site worrying about tool changes or puck changes. So it's going to keep your production productive. As always, with all of the Roland and DGShape equipment, the V panel is included, available for download on our site. The V panel is basically the brain of the mill, telling it when to start, stop, calibrate, cleaning procedures, and all of your maintenance that would need to be done. So that is included with the machine purchase and is available for download on our website. Something that's important with a lot of these new materials out on the market, not just your zirconia or wax materials, but when milling PMMA, TriLor, or even denture bases, we have an ionizer inside of our machine. The suction unit connected to your mill will actually generate some static which travels up the hose into the machine, creating a static charge on the inside of the unit in the milling chamber. So without the ionizer, you're actually going to see a lot of that material stick to the internal parts of the machine. I'm sure some of you have witnessed this. Not a big problem, it just increases the time that you have to spend on your maintenance and cleaning the actual unit itself. So the ionizer is very important. It is going to reduce that static, allowing that mill debris to drop to the bottom of the mill and be evacuated out of the back. So a much cleaner machine. A clean machine is a running machine. And last but not least, air pressure. In some of our older units, you had to adjust the air pressure manually. In the new machine, the V panel is going to be able to identify which type of material you're going to be milling and adjust the air blowing pressure accordingly. So more for your convenience, less manual steps for you to have to take care of. So when Daniel and I first started talking about Roland mills and TriLor, one thing that we wanted to do was perform some tests. We wanted to mill some jobs out and see what kind of information we can gather from our experiments. So here in this first test, one of the cases that we milled is a 3-unit screw retained bridge, a substructure. It has 2 implant sites, it has a gingiva area, and has 3 preps. So we went ahead and we nested this job in Mailbox with a 16 millimeter TriLor puck, and we used the Roland carbide milling tools. So carbide milling tools, you have an option when we talk about milling tools for cutting TriLor. You can use your diamond coated tools, they'll work just fine, or you can use your carbide tools. Obviously a cost difference there, also a life expectancy difference. The diamond tools will last longer on things like zirconia, but due to the way that TriLor is manufactured and those fibers that give it all of its strength and the properties that we like, those fibers actually do generate a little bit more heat when cutting. So opposed to using a diamond coated tool, which is actually going to generate a little more heat, what we've found is that when we use the carbide tool, which is the more affordable tool of the two, we actually reduce the amount of heat generated when cutting those fibers. So we recommend the carbide tool. Mailbox Sim System has also tested the material, and they also feel that carbide is probably the right solution here when we weigh cost versus tool life. So again, you can use both tools. They'll both cut this material just fine, but carbide is what we tested here. So this case here, this substructure, took us 64 minutes to complete. And it came out successfully. We had no issues whatsoever. One of the other things that I'll point out when I did nest this job, the space here between the restoration and the wall of the puck itself is called the offset. And what I did is adjusted the offset from 2.7 millimeters of space up to 4 millimeters of space. And the idea behind that is with undercuts of gingiva areas and margins, we want to make sure we mill out the maximum detail. And I want to give that tool as much room as possible to reach those undercuts. So by giving it more space, oh, sorry about that, in this area, we're actually protecting our tool from breakage, and we're going to get a better milled restoration. So a much bigger case here, our next test was a TriLor bar and an 8-unit cutback bridge. So here we see our bar, and then we have our cutback bridge here with a facial cutback, multiple implant sites. Again, we used the very same puck that we used for our previous job, a 16 millimeter, and we used Roland carbide milling tools again. And these two restorations together took a total of 246 minutes. So we didn't use any of the newer flat end tools, the time-saving tools on this job. That was before the newest Mailbox update came out. So we probably could have saved about 15% off of the milling time on this, but we did calculate this with a previous version of Mailbox itself. So 246 minutes to be able to produce your own bar or large cutback bridge that could be wrapped in a composite material, veneered, composite placed on it. Having the capability to produce that in-house compared to outsourcing these larger restorations, like a titanium bar, is significantly different. You design during the day, you load your TriLor puck into the machine before you go home for the night, click start, head home, worry-free. You come in the morning and you have a bar ready to be removed, and you can continue your workflow. You're not waiting 3, 4, 5, or 6 days to receive a titanium bar back from an outsourcing location, which you can receive it, place it on your model, and find that maybe there's something off. Maybe there's something incorrect. This is going to give you that control that's going to give you the ability to produce these cases faster and easier. So great success on this case again. Same thing as I did with the other case. I increased the offset space to 4, and we had no issues. No tool breakage, no damage, and clean milling of the material itself. So here you'll notice an image of that actual puck itself. So we have our bar here, we have our 3-unit substructure, and we have our cutback bridge. Everything is nice and clean. The mill stayed nice and clean. That the ionizer helped reduce the static charge on the mill debris generated from the material itself. And we even cut some restorations that we typically wouldn't necessarily mill. We milled full contour crowns, full contour bridges. We just wanted to test this material and all types of capabilities. So once you purchase the puck and place it in your Roland mill, you know that you're going to have success. So set yourself up for success. Through our testing, we came up with just a few tips. We've already touched on the first one, which is we recommend carbide tools. Again, you can use your diamond tools, but if your diamond tool is rated to last about 50 hours and you're using it in this material, you may see it slightly reduced just based off of the heat generated between that diamond coating and the fibers itself. So carbide for the cost seems like the right solution. Again, increase your offsets in restorations that have deep undercuts or gingiva design. And in the newer version of the Mailbox software, those strategies do call for some new tooling. So the new tooling are our PT1 and our PT2 tools. Those are our flat end tools, which are called upon when milling implant sites or bars. Bars may have flat surfaces. The implant sites are probably going to have 90-degree angles where tie bases or abutments are fitting into them. So to mill that detail as best possible, your Mailbox software for your Roland mill is going to call on those flat end tools. So when you're considering getting ready to start a case like this for your first time, reach out to your Roland dealer or contact Roland directly and get yourself a set of the PT1 and the PT2 tools just to have them on hand. So reduce milling speed when possible. If you're milling a job overnight and you know that this bar is only going to take a couple hours to produce and you want to protect your tools and your machine, go ahead and go into the V panel and reduce your milling speed by 10 to 15%. That's going to slow the feed rate of the tool into the material and ultimately protect your tool. And it's also going to give your restoration a nice smooth finish and giving you an overall better product. One of the biggest suggestions that I can make to you is if you're a current user of Mailbox or some 3D with your Roland mill, we highly recommend that you upgrade your software to the Mailbox 2020 software. This is going to have the latest and greatest cutting strategies and call on the latest tools available to give you the best restorations that are going to fit the best and increase your productivity. Oh, sorry about that. So really quickly, open up the Mailbox and I'm going to show you how easy it is to really get your system set up to run here. Okay, so this is the main screen when we do open up our Mailbox software, and you can see that I am on the 2020 version. And Mailbox has taken the time to take a look at the material and our machine and how they work best together and come up with the best milling strategies. So this is what your Mailbox software is going to look like. Very simple, very user-friendly, very low learning curve for if you have a new user. The first thing we're going to do, as with most softwares, is we're going to click a new job. And you can see here, regardless of what type of rolling mill you have, maybe you still have your 50 up and running, maybe you've purchased the 51 or have our newer 52 series, your machine is available inside of this Mailbox software. So for demonstration purposes, I'm going to go ahead and select the 52D. My next step is to choose the material type that I'm going to mill. And we can see very conveniently here, TriLor is a material option in the software already. So the strategies are created, and SimSystem has taken the material and machine into account to give you the best strategy. Last but not least, I'm going to select the fixture that I'm going to be putting it in and choose the check mark. And it's as simple as that. I mean, at this point, all we would do is choose our type of restoration that we're going to be milling after we've made that material selection, adjust our offsets, set our sprues, and calculate the job to send it to the mill. So it really couldn't be easier. So with that, I will hand it back off to Daniel, who is going to review some TriLor restorations that have been completed. Yeah, we hear you.
Yeah. All right. So thank you so much, Ian, for that that great demonstration, and certainly with the Mailbox. But you know, it shows that, you know, certainly Roland as well as Mailbox have you know, validated and looked at this type of restoration and included it into their CAM software, which is fantastic. So for all of you that are Roland users out there that are using Mailbox as well as others, and there's plenty of you know, ways of doing that, but know and rest assured that it's been, you know, worked on, and as Ian said, we've tested it quite a bit and checked to make sure that it's functional. The offset is what's really important with what Ian said, is that you want to make sure that it's greater, and I think, Ian, you said 4 millimeters, if I'm not mistaken, of an offset.
4 millimeters, but typically 4 millimeters on a 16 millimeter puck. Once I start crossing over that 16 and 18 millimeter puck with large restorations, I tend to increase my offset a little bit more. So when we cross that threshold of 18-20, I would consider bumping it up another millimeter or a millimeter and a half. It just as a precaution.
Excellent. Excellent points. And these are, you know, this is images of what you can do with, in courtesy of Jay Black. He provided these, and you know, and this is the TriLor material. But you know, what I want you to notice, and why I chose these images, is look where the access holes are coming out of. You know, now with the access holes, you know, with this type of bridge, you no longer have to worry about it, and it's still, you know, screw retained. It's still a screw retained restoration, implant supported bridge with individual crowns. These are, I believe, Emax, if I'm not mistaken, but he was able to create this, and then with composite, he was able to restore the gingiva as well. But look at the aesthetics. Look at, you know, where the screw access hole is coming from, and there are two that are underneath the crowns as well. But it's really a versatile, you know, and the ability of doing that is you know, it's not that difficult once you start designing, and once, you know, with the strength and the support of the mill, you can really achieve some remarkable results, and as Jay Black demonstrates here. But then the next question is, how do we go about with bonding it? Because that's always a question. Now, you can bond with either composite or bond to, rather, either composite or acrylic. But in reality, what you want to do is you want to use you want to first sandblast prior to, once everything is done, it's milled, it's cleaned and everything, you want to sandblast the TriLor with you know, with aluminum oxide, obviously non-recyclable aluminum oxide, anywhere from 50 to 100 microns at no more than 2 bars of you know, pressure. So you want to make sure, because it is a polymer and there is composite in it, so you don't want to over blast it, but you want to just be able to clean it. Then from there, you would take it over to clean it with air. Make sure that whatever air in the compressor that it is oil free, because the last thing you want to do is introduce any other contaminants, because contaminants will affect the bonding strength or the bonding success of the material. So you want to make sure that it is clean, and therefore we sandblast it, but you want to make sure it's clean and oil free, and that includes also with touching it. Then you want to treat with silane or allow to evaporate for about 5 minutes. So it's just, you want to clean it up, and then apply acrylic resin or composite directly to it. So if you're using a composite, as demonstrated with Jade Black's case, and what I always say and what I suggest is that any composite that you utilize today can be used on TriLor. If the composite comes with a primer for composite, then use the primer. If not, then it's okay. The primer just allows for an additional strength or bonding strength for that composite. Now realize that composite is 25% of what the TriLor is. So it's bonding like materials to like materials, which bond really well. So the primer certainly helps, but you can also bond directly to it. If it's acrylic or you're wrapping around a bar, a hybrid bar, rather a overdenture over a bar, you don't need to prime it, but you do need to nonetheless treat it, as we said here, all the way through from sandblast to clean to treat. Again, just as a recap, and thank you for your time here, but TriLor is a versatile and very exciting material. It is, as I said, metal-free, biocompatible, very light. It eliminates headaches because of this lightweight. And just as a comparison, we've also compared a similar arch. We've done the same arch for the same patient, one with TriLor with the individual crowns and one with zirconia, and weighted, just to kind of get a sense of what the difference in the weight is. And it's significant. It's 21 grams as compared to 51 grams of zirconia. That's something that could be felt, and something that, even if it's not felt by the patient, could lead to some unintended consequences such as headaches and so on and so forth. So utilizing the TriLor material, the polymer, the Techno-Polymer, provides so many benefits, as I said, to the laboratory, to the clinician, and certainly to our patients. There's other opportunities to use TriLor as well. There is I just want to honorable mention, there is an analog arch. So if you're interested in using TriLor, but it's analog, there is, and it comes in these type of arches, and it comes in 3 different sizes, 3.5, 5.5, 7.5, that you can, kind of with a handpiece, just trim it and create it to where you want it to. It's for those of you that are using the chrome technique, which is sequencing surgical guides, some have found great success with this, as well as we do have some videos with Oscar Galvez doing a case such as this. But with CAD/CAM, what we're speaking about here, you can certainly do implant bars with thimbles. You can do it over telescopic coping. As I said, Deutsch does those as well. You can even do long-term temporaries, for these very strong. You can do substructures, as you see here, with a overdenture or another type of, like a crystal ultra that fits over it. Some people even do partial framework, as well as splints, bite splints, and so on and so forth. So the ability with this material to really utilize a lot of different functions with it. You have the way of designing it, you have the way to to mill it, certainly, as we know, and it's just the control is what's the biggest thing. Not only is it benefiting everybody, but certainly the control. So with that said, I just hope everyone enjoyed. It was a great wealth of information. Again, thank you so much, Ian, for the wonderful show of what the capabilities of the Roland DGShape can do and how to accomplish it. So thank you for that, my friend.
Thank you for having me, Daniel. I appreciate the time.
And thank you, everyone, for joining us today. I hope you found this very informative. And if there's anything, either Roland or myself can help, feel free always to give us a shout out. Okay? So all is well, and we'll talk soon. Thank you so much, everybody. Bye-bye.
Thank you, everyone.